Okay, so I'm going to do some more problems. I just thought I'd pick out some problems that will help you with your homework. And when I looked at your homework and tried to find things that might match up, as you get into your homework, there are problems that there isn't a perfect match. But I tried to find ones that give you more instruction so that you can go back and go, oh, I remember seeing some kind of technique in that problem, and you might be able to use that technique again. All right, so let me see. This problem, it actually was from your book, number 103, and it actually is piggybacked off another problem. So apparently this must have happened. There's a lottery in Pennsylvania, one of those ones with the ping pong balls that go into the little pop-out things, and they give you the numbers one by one with the ping pong balls. So you've seen that on TV. And so what they did is they put liquid into everything but 4 and 6. Somebody did. So it was rigged, so that guessing the actual numbers that come out becomes easier if it's not unbiased, it's biased because they put liquid into some of those balls and they're not going to come up, they're heavier weighted. So that was the original problem, and they had a follow-up problem where they said, okay, right after, so the number turned out to be 666, and then right after that, Connecticut also got 666, and so everybody went crazy and said, there's something up. You know, we got 666 on the Pennsylvania one, and we're getting 666 on the Connecticut one. So the first question is, what's the probability a 666 would be drawn in Connecticut, given that a 666 had been selected in the Pennsylvania lottery? So in your homework, you'll have to do it like this too. Set up your event. A is the event that 666 is drawn. I have another problem that I work later where it's not clear what the events, I think that it's confusing sometimes to know what the events are supposed to be. This one is a little clear. It's an event that a 666 was drawn in Connecticut. And the probability of A, you have 10 numbered lottery balls because they're ping pong balls labeled from 0 to 9, and there's 10 of them. So drawing a 6 out of the first, if they're equally likely and they haven't been biased, is going to be 1/10. Doing it 3 times was independent. So they just put the balls back and then do the little pop-up thing again and pull out the second one. So you multiply those events. And I don't know if anybody took 206Y. I think they started that. But if you took the regular 206, they did this. This is a multiplication rule that you learned early on in the semester when things were good. So that's the first. I'm just using that. So far, so good? And this was, I was disappointed that I chose this problem because it turned out to be really easy, but some of your problems are like this too. So okay, maybe it's okay that I gave you this one. B was the event that 666 was pulled in the rigged PA lottery. I really don't know like how that would work out. I would think that only 4 and 6 could really be pulled. But I just went to the definition of conditional probability, which is on definition 2.9 in your book, as some of you already put on the board. And A and B are independent of each other. The fact that someone injected liquid into the Pennsylvania one has nothing to do with Connecticut. So on the other theorem we just talked about, if they're independent, then probability of A times probability of B is equal to that intersection, and I just cancel, and I get 0.001. So there is, I think, a problem that you have to do, which is straightforward, where you're just calculating based off the definition of conditional probability. Any questions on this? It's like straightforward. I like the mix of problems. I think last semester we gave every single one was hard, and we gave 10 of them. Now you have some that are kind of straightforward and some that require more thinking.
Are all the problems in the homeworks going to be equal?
I didn't weight them equally. So what I did is I gave you, like, if there was a more difficult problem, there was more to learn out of that. So I would kind of look at the mistakes people had, and usually it varied by student, and then I would give hey, dig up this definition, could you really apply what you're doing? Or why did you not justify this? So there would be some questions. And if you resolve all those questions and they were minor, I gave you full credit back. If they were more major, then it depended on what I asked you to do. So I kind of gave you a code book so how you get back those points. So you have a problem like something like this. I think it's number 6. I'm not sure, but I felt like you had something where you were doing something and then you needed something to happen first and then something else had to happen. Anybody look at all the problems yet? Remember something like that where you had, I thought there was something in your homework that it had this kind of a thing. Number 5? Yeah, I remember seeing it. So 2 die are tossed over and over an infinite number of times, and the sum is recorded. Because there's somebody who has that kind of time. They're just rolling die, that's all they're doing. And what's the probability we obtain a sum of 3 on those 2 die before we attain a sum of 7? So these are confusing because you're doing something over and over again infinitely. So you're going to have a series in there because you're adding up probabilities. So first define events. And this was the example that I told you about where it was not clear what the events had to be. So I'm going to develop them like a human being would develop them, not like the coded example that has everything. Oh, event A is this, event B is this. This is how I think I'm normal. Maybe I'm not normal, but I think a normal human would do it this way. So what is, if A is the event that the sum is 3, what's the probability of A? What's in A? That's it, right? You either roll a 1 first and then a 2, or a 2 first and roll a 1. So that's all there's in A. There's 36 total possibilities. I think you guys did this in 206 where you had a lot of die stuff and you had to list them out. So your total sample size has 36 things in it. There's only 2 guys in A, so the ratio is 118. And I shouldn't have done that. I actually reduced it as a habit. You'll see later that I go back to the 2 over 36 because I'm adding fractions. In an infinite sum, so it's not that you can just put it on Mathematica. Well, yeah, it can put it on Mathematica. Yes. So how do you get a sum of 3 before you get a sum of 7? Well, I started making a table. So I roll. How could that happen? Well, I could roll first, and A has to happen right away. That's how I get the event A happening, if I only rolled once. If I rolled twice, well, first, I didn't get a 3 or 7, and then I had to have A happen, right? The sum of 3 or the sum of 7 shouldn't have happened. Because if a sum of 3 happened first, then I've got it, I'm done. So to have it on the second roll, it means that I didn't get a sum of 3, and I didn't get a sum of 7, and I ended up on the second roll getting it to happen. So it's A that's the holy grail. That's going to be my end result. On the third roll, to get the sum of 3 happening before a sum of 7 means I didn't get 3 or 7 on the first or the second roll, but it happened on the third one. Right? I don't want 7 to come up first, and I don't want 3 to come up first in order to have it happen on a third roll.
Yeah. What do you mean by and then A, like your roll number 2?
So if I had 2 rolls, and it happened on the second roll, the 3 came before the 7, it meant that the 7 didn't come on the first roll, and the 3 didn't come on the first roll either, because then I'm back to this case. Right? I just stop the game as soon as I get my 3 happening. So that's what I'm trying to describe.
Would you also stop the game if you get 7?
Yes, and that's why I don't want the 7, this or that can't happen. And that tells me what my other event has to be. I need to define a second event because I keep describing this, and I don't like to write because I'm a mathematician. So B is the event that the sum was not a 3 or not a 7.
Is it redundant though to have like 3 or 7 and then A, because A is the event that 3 was rolled? Or that you got 7? Or sorry, that you got
I just
3.
need a 3 to happen before the 7, right?
Okay.
And if I'm tossing it an infinite number of times, a 7's going to happen, right? So I just stop the game when I get the 3 done, right? And the 7 didn't. I need the 7 not to happen before I rolled the 3.
Okay.
Did you guys work on things like this in 206? No? I can't actually imagine some of the English or history majors enjoying it if you guys did infinite sums in there. Did you guys do infinite sums?
We didn't do it to this degree.
Okay. Well, I'm giving you my thought process so that's not just the cooked answer.
That makes sense. See, like, I think 206 would have made this a lot easier. It's like if you gave the person a set number of rows so that they could actually figure out a probability. That makes sense.
Oh, you know what? You do it in 206 when they say how many ways can this happen. So I'm just like looking at how this could happen on the second roll, how this could happen on the third roll. So I'm just looking at it that way. So I'm making my table, and from that description, I see that, oh, I keep having the same thing here, the same event. And so I'm going to call B that second event, that I didn't get a sum of 3 or I didn't get a sum of 7. So what would the sample, so remember how I did probability of A and I figured out what A looks like? What would the opposite of this guy, the other guy that I had? So it's easier, if not getting a 3 or not getting a 7 is hard to think about. So I'm going to think of the opposite. Getting a sum of 3 or a sum of 7. What would that sample or that set look like? There's going to be several things in it. 1, 2, and 2, 1 is going to be in it, because that's a sum of 3. You don't want to stand up again?
Does the order matter in this case?
No, it does. Order matters, right? Because you're doing it in order. Roll 1, you're throwing the 2 guys. So if you have 1 or 2, 2 or 1.
So,
You'll have 6 more.
Subtract.
28.
It'd be 6 more possible.
So what I got, you could get 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3, and then your 3s. Is that correct? I'm actually terrible with numbers, so you have to watch me on the numbers. Probability of that above guy is 836 or 2/9, which I shouldn't have done actually. You'll see that I need to keep it into unreduced fractions. Why did I do that? Because probability of B is so hard. I just did not B, and then probability of B becomes 1 minus 2 minus 7 minus. So that's why I did it that way. And that comes up a lot in this class where there's something you need to calculate the probability of, and it's so enormous and so hard to figure out that it's easier to do the opposite and then subtract it from 1. So if you go back to my table, instead of putting the not business and writing it with little things underneath it, hash marks underneath it, really I want this A to be the end all of just one toss. BA is the end all for the 2 tosses. BBA, so I'm looking at actually what you did in 206, the number of ways that you can have this happen on each of these tosses. And there's my ... It goes on forever. So I need my event C. The event C is the sum of 3 appears before the sum of 7. Well, this is the ways it can happen. This, or this, or this, or this, or this. So these are all the ways it can happen. So what would I fill in for that blank?
Speed up.
Sum, right? You're right, summation, right? Probability of A. Some of these two, this and this happening in that order. This and this and this happening in that order, right? So I'm going to add up all those probabilities. There's nods. Are the nods I'm falling asleep? So when someone cooks an example for you and it's done, even the way I'm showing you, it looks easy. But when you're doing this on your own, it does take time. And that's like, I told you, one of the things I've seen over teaching these type of classes is the amount of time you have to adjust for it. It's not an integration by parts. It's something more involved. And I'm gonna give you the specific feedback that the former students gave, so that you can see it in their writing. But they said doing it together as groups, working together, and then coming into AI, resolving anything you couldn't get by text. So sometimes it's hard to explain things by text, or you might not fully understand it. And all of those are important, involving everybody in the discussion. Why am I allowed to do this? Now I need my little justification. I kind of was doing a physics type or engineering type of argument. No offense to those guys. They need to get stuff done. They don't have time to sit around and prove things. But why? It's the union of all these guys up here, and they're all mutually exclusive, right? If this happened, you're done. That's independent of this happening. That's independent of this. There's no intersection in those sets. And so that's why I'm allowed to split them up like that. Seth?
There's process.
I see. Shaky?
So how would you calculate rule number 2? So when we ask color B then A, that's like given B then A, right?
Yes, and they're independent, so
Then we use that multiplication.
yes, that allows us to separate by the plus signs, and then voila, now we're at the numbers. It took me a long time to get, even just to explain it, to get to the end, but I'm showing you my thought process to show you it's not just, hey, I just got to the end like that, magic. And now it turned out to be, this geometric series just comes up again and again. You know, when I teach Taylor series, I would say, oh, geometric series is so important, you'll see it again, and no one cares. There it is. It's a geometric series. It's a convergent geometric series because the x is smaller than in between -1 to 1. Bringing back some good memories. And then it's 1 over 1 minus r. Crank it out, and I get the exact 1/4. I'm handing out a sheet just to, I like to take the temperature throughout the semester, and I think we are done. So just give me the 5-minute warning. I'm like Forrest Gump, I'll just run past the goalpost. So if you guys can text me and let me know, so that I know you didn't text me yet. So
Wait, so what is 1/4 the answer?
it's the probability of C, which is what I was after.
Okay.
So when you're doing your homework, you might be struggling to get what that set is that you're after. So break it down into little sets. Some of it might not be useful. You have some notes around you. You can always text me and say, hey, I was thinking my event might be this. I might redirect you and say the event might be this. So give yourself that time.